Okay, welcome to Solving Trig Equations Part 3. So we're going to see how many we can get through in this one. Maybe we can get through the rest of the examples that I had planned. But if not, I guess we can do another video. But of course, if you're coming across any equations that you don't know what to do with them, please feel free to email me and let me know what you need to go over. Okay? All right, let's take a look at this first one. This one is different than any of the ones that we've done before. And why is it different? Because this is not just an x or just a t. Now we have a 3t inside, okay? A 3x or whatever you're solving for. Okay, so that's going to be different about this one. Now, I'm going to do everything the same way up until that point. Are you ready? So the first thing that we do, and this pen isn't very good, so let me get another one. The first thing that we do is, of course, solve for cosine. All right, now there's two things that we can do here. If you're okay with, going forward, you can, once you see it a few times, maybe you can, skip kind of some of the steps. But the first thing I'm going to do is I'm going to say let 3t equal u. All right, so I'm going to change this to cosine u is equal to 1/2. Now, why did I do that? Because this one I don't know the answer to, but this one I do, because these are angles that I know, right? This is a one that I know. I know that it's going to be, well, what will it be? Let's take a look at our reference angle, right? So this one's pi over 3, pi over 6. I was just seeing which one was bigger, but I don't think I really drew it to scale anyway. Okay, so I know that the angle I'm looking for, the adjacent is 1 and the opposite is 2. So that's my reference angle, right? What quadrants would I draw it in? Well, what quadrants is cosine positive? I'm going to draw it in this one and this one. So this one is obviously my, what did I say, pi over 3. And this one is my 5 pi over 3. Those are my two angles, okay? All right. Now, once again, we're going to do this one both ways. We're going to do it, between 0 and 2 pi. So the first one that we're going to do is between 0 and 2 pi. And then we'll do all, okay? So between 0 and 2 pi. Well, between 0 and 2 pi, I know that u is equal to pi over 3. And u is equal to 5 pi over 3. That's what u is equal to. But u is actually equal to 3t. And t is the thing I really want to solve for in my equation, right? So how will I take care of this situation? Well, I'm going to divide both sides by 3. So I'm going to do, I should have done it over here because it's kind of hard now, by 3. So of course, this is going to be t is equal to pi over 9. And this one, when I divide both sides by by 3, I'm going to have 5 pi over 9. So these are my two angles that I'm going to start with. The trouble is, let's think about this for a second. My period for cosine is usually 2 pi, but that is actually not the period of this function. Do you agree with me? This one is different because I have that 3 there. What does a 3 inside of my function do? That causes it to compress horizontally, right? So if I had cosine, right, if this were my, pretend it looks nice, all right? If this were my cosine, this would have been 2 pi. So if this is y is equal to cosine x. But if this is y is equal to cosine 3x, well, what has to happen? I actually have to have 3 of these inside here, right? Between 0 and 2 pi. It's going to compress it by a factor of, my period's going to be 2 pi over 3. So I actually have to get 3 of these in here at this point if we have a compression like that. So I would have like a thing here, a thing here, and a thing here, let's say. So you thought that one was ugly. Wait till you see this one. So let's pretend again that that's, beautiful. And this one is y is equal to cosine 3x. So if you notice, between 0 and 2 pi, usually this has like 2 places that have the same output, the blue one, right? Between 0 and 2 pi, because the period for cosine is 2. But with cosine 3x, well, look at what happens. Here would be the two solutions, right? Your two solutions that you would have for, like pick any place. You could pick this one and this one. I just didn't pick up here because I didn't really make it tall enough, right? I guess. So it would be these two, but then it would be this one and this one and this one and this one, right? All of these are between 0 and 2 pi. So what happens is you've squished in more waves. So this doesn't always just cause a horizontal compression when you're looking at the picture, but what ends up happening is when you're solving these equations, it actually is going to triple the number of solutions that you have. Okay? Let your brain wrap around that for a second. And this is the reason why, because the red one is the picture, and between 0 and 2 pi, you get way more curves inside there. So that means there's going to be more times that you're at that same output. Okay? So these are my first two, but I just said that there's way more curves in there. So really, this one and this one were my first ones. So what I found was actually the same two, but I still have, that would only be two, and then I have 1, 2, 3, 4 more to find. Does everyone see what I mean? So I have a lot more to go. All right. So how am I going to find those ones? Well, what did we just say the period of this function was? The period, of course, is 2 pi divided by that coefficient, because the regular period is 2 pi. This is a compression by a factor of 3, so that makes my period 2 pi over 3. So in order to find those other angles, what I'm going to do is I'm going to take my angle and I'm going to add 2 pi over 3 to it. And I'm going to do that a bunch of times, well, until I find them all. Okay, so remember, this is if I'm looking for the between here and here. Okay, so I'm going to change 2 pi over 3 to something with ninths. So that will be 6 pi over 9, right? And why did I change it to ninths? Because these are both in ninths. So if I'm going to add my period to it, it makes sense to change it to ninths, right? So really what I want to add is 6 pi over 9, and that will give me a 7 pi over 9. So now I have to stop and check, is that still between 0 and 2 pi? And the answer is yes. So this was our first one. This one's good. I'm going to add another 6 pi over 9, so it'd be like spinning around again. Think about if our unit circle got switched so that instead of a whole spin around, it was 2 pi. Now our whole spin around is 2 pi over 3, right? We're trying to find these other guys. So that one will be 13 pi over 9. Is that between 0 and 2 pi? And your answer is yes. Now, I already know this next one is not going to work because I know that this is a horizontal compression by a factor of 3. And that means that there's 3 times as many waves. So that means there's 3 times as many solutions. So I'm looking for 6 solutions. I know that I'm looking for 6. So I'm pretty sure these are all of them. But of course, if you didn't know, if you were just, again, weren't sure, or you, sometimes you forget, you just keep going because you're in a groove. So this one is bigger than 2 pi because 18 would be 2, right? So that one's too big, no good. Now we do that same thing with 5 pi over 9. And I'm going to add 6 pi over 9. So we know that he's good. When I add 6 to that, 11 pi over 9, still small enough. Add again. I know there's going to be one more because of all what I just said, right? I know that I'm expecting 6 solutions. But if I add it again, you're going to see it's too big. So that will be, what, 15? No. What's 7 and 6? Is that 17? Yeah. 6, that's 14, that's 24. Not 23, sorry. Too big. In any case, it's too big. It's 20-something, right? It's too big. All right, so I know that these are my 6 solutions to this between 0 and 2 pi. Make sense? So those are my 6 solutions. So if I were writing them, it's these ones plus, and then my 11 pi over 9, my 17 pi over 9, my 6 solutions. And why? Because this was a 3. If this were a 2, I would be expecting twice as many solutions. So I would have expected, 4. If it had been 7, I'd expect 7 times as many, and I would expect 14 solutions. Does everyone see what we're talking about? Because you'd fit more curves in there. All right. Now, once again, if we're talking about all solutions, this is a different situation because we can keep spinning around forever and ever and ever and ever and ever. And normally we just add 2 pi k to the end. The trouble is we can't just add 2 pi k. What am I going to add this time? Well, we just said my period is 2 pi over 3, so that's when things start to repeat. So I'm going to say plus 2 pi over 3k. And exactly, I mean, you know, like, just think about it. Isn't that exactly how we found these other solutions? We added 2 pi over 3, 2 pi over 3, 2 pi over 3 to find these other ones. So obviously when I say plus 2 pi k, it's going to find that one and that one. And if, you know, it's negative, if the k is negative, it's going to find the negative values. So that's the first one, and the second one is this. Now, once again, if you aren't good at finding the period of your functions, which I hope everybody can find the period of these sines and cosines and whatever, the other way that you could do it is you could say that u is equal to pi over 3 plus 2 pi k. So you remember we had the pi over 3 from our triangle and all of this when we made u, you know, 3t. And then we said that that's equal to 3t. So when we divide everything by 3 here, this one becomes pi over 9 plus 2 pi k over 3, which is 2 pi over 3k, right? So you can do it that way too. If you want to set it up with the period already and then divide everything by 3, you can do it that way. But I just like to say, oh, I know what the period is. I'm not going to bother with that. But, you know, you can do it either way. Okay. Let's look at these next two. So if this were a 1/2, you would expect to have a horizontal stretch, and what would happen is you'd be pulling this outway, and you'd actually expect to have half as many solutions, right? Because if you're pulling this out, like this solution often gets pulled past 2 pi, if we're talking about this blue one. So when you have a horizontal stretch, you're going to get less solutions. And when you have a horizontal compress, you're going to get more solutions because you're squishing more waves in there. Okay, we'll do some more of those ones, but let's move on to this one here first, and then we'll do more of those. Now I put this one here because this one comes out funny, and it actually turned out that we talked about it in the last video anyway. But so this is going to be a 6. So cosine x is equal to 3. And hopefully everybody knows when you look at this that this is no solution. And why? Because think about your cosine. Its range is -1 to 1. There's no value that I can plug in here to get a cosine of 3. So this one is no solution, right? So if this is bigger than 1 or smaller than -1, you know you have a situation where it doesn't work.